Let's take a look at equivalence partitioning. What is an equivalence partitioning? The idea is to gather and collect all the possible inputs of a software system and divide them into groups that are expected to exhibit similar behavior. So, the idea is that you take a look at what you can enter into your software product as a user and then observe the results. There are a couple of entries of data that you input that produce the same result. So you can group those inputs into groups. Equivalence partitions are also known as class partitions, are identified both for valid data, the values that should be accepted in your system, and your system should produce an expected result and should produce an output for your input, And there is also partitions that are directly related to invalid data, the values that should be rejected from your system. We can select one input value, and that input value is considered to be the representative of each partition or class. So you choose one, you pick one value from the class, from the partition, and you can use it as the representative. So that value will produce the same result as every other value in that partition. So partitions can also be identified for outputs, where you look at what the system provides to the users as outputs, and you can group the outputs and then go back, do the opposite of what we are doing up until here. So you don't start with the inputs, you start with the outputs. You group the outputs and you consider that those outputs are the same, and you try to find the inputs that produce that outputs. And then you choose one representative, because this is always the same output for a couple of input values. You can and you should also test internal values that aren't quite visible from the outside, but you know that when you submit a couple of inputs to your system, there are a couple of internal values that should be tested and should be accommodated also in your partitions. Time-related values. This is basically related to events, and currently there's almost 1,000. Another important aspect is when you have time-related values that are directly related to events. So you have an event that occurs and you aren't able to actually predict when that event will happen, because if you were talking about notifications, a notification when it happens, it isn't pre-scheduled. It happens because something happened, And you have to imply and you have to accommodate the before that event happens and the after that event happens. And that is a good example of two partitions that are identified because of time-related values. Another important aspect, and currently there are a large amount of software products that use an architecture that consumes a RESTful API, for instance, and interacts as usual with other components and other modules and even other systems. There are interface parameters that are sent to an API, a REST API, that are sent to another library, that are sent to another system, and that are inclusively, sent back. So you should also test values that are related to this communication of integration with other systems. 10 tests can be designed to cover all valid and invalid partitions. Equivalence partitioning is applicable to all levels of testing. So despite being a black box technique, this is an example of something that can be used even at a unit testing level. So yes, you can actually apply this technique, that is a black box technique, when knowing the structure of your code. It can be used to achieve input and output coverage goals. So if you have a large amount of integer numbers, for instance, you don't have to test all the numbers if you can subdivide them into classes and then choose one element to be the representative for that class, and you can state that you have tested all the values in that class, okay? So it's a coverage goal. It can be applied, and it should be applied to every human input that your software product receives, inputs that are received via interfaces to another system, or parameters used in integration testing. Let's take a look at an example, a brief example. You have this requirement, and I will read the requirement in a short while, and let's consider while reading the requirement, what is the partitions that are involved in this requirement. So the requirement is, the customer is eligible for car insurance if they are at least 17 but no older than 75 years of age. Age can be entered in the range 0-999. We have seen a couple of numbers appearing in the requirement. So yes, we can take a look at 17, 75, 0, 9099. So there are 4 numbers present in the requirement that should be used somehow. If we try to divide what is the input that the system receives, because the input is the age of someone, okay, the expected results are mainly related to the fact that that person is eligible or not for car insurance. So if we divide the scope that is presented, we can actually state that since age cannot be entered below 0 and above 9999, we can actually consider below 0 and upper 999, we can consider them both as invalid partitions, okay? But then we have 3 other partitions available between 0 and 999. And from 0 to 16, we consider it a valid partition, but the user or the person, the customer, is not eligible to receive a car insurance. When we are considering the other partition, 17 to 75, it's also a valid partition because the age is correct, is acceptable by the system, and the person is actually eligible for a car insurance. If we consider the partition from 76 to 999, it's also a valid partition, but the person is not eligible for car insurance. So we can actually see that we have 3 valid partitions, 2 invalid partition, and that goes to a total amount of 5 partitions. From the 3 valid partitions, we can also do that for the invalid partitions, but we can choose one representative to be the one responsible to exercising this partition. So from 0 to 16, we can choose, for instance, the value 10 and say that it is the representative for this partition. For the next partition, we can choose, for instance, value 50, and 50, and actually say that it is a valid, we get the eligible result, and this implies that all the partition is tested. For the last partition that is considered valid, if we choose, for instance, 100, okay, we have a valid partition tested, and all these numbers can be considered covered by that representative.